Welcome to Getting Started with Houdini 1. If you're new to Houdini and you've been having a bit of a difficult time finding your way around the interface and understanding the various view modes and that sort of thing with Houdini, then this is certainly the tutorial for you. In this tutorial will look at view modes, selection modes, geometry types, basic curve construction and curve editing, creating objects in context, channel referencing, basic expression syntax, and several more tips and techniques to help you getting started with Houdini. At the end of this tutorial, I would certainly recommend that you look and consider Getting Started Tutorial 2, where we'll look at in more in depth of procedural modeling, polygon modeling, texture mapping, UV editing. But this is certainly a great tutorial for anyone looking to get started with Houdini and truly understand the Houdini interface. Welcome to this Getting Started tutorial with Houdini. The intent of this tutorial is to help you become extremely familiar with the Houdini interface, its windowing system, and to just find your way around so that you'll be able to move on with more advanced projects. Now, when you first install Houdini, there's a number of system preferences in effect, and I've actually changed a few of those for this tutorial. And I think as a new user, because you're not particularly familiar with the interface and Houdini in general, I think it's important that you set those preferences to match mine as well, so that when I'm telling you to do specific things, things are looking the same as they are in the tutorial. Now, the user preferences, as you become more familiar with Houdini, you may find that you want to change some of these to your own liking. But for now, I suggest that you follow along with me and set them up the way they've been set up for this tutorial. So what I'm going to have you do is go to the Edit option in the menu bar here at the top, and I'm going to say Edit Preferences, General User Interface. Now, there's nothing really here in the general user interface preferences that I want to change. So I am going to have you click here and change to 3D viewports. Now, the first thing you want to consider here is the tumbling method. By default, this is set to the 80s tumbling method in your copy if it's a fresh install of Houdini, and I tend to like classic Houdini tumbling. So I've switched the tumbling method here to classic Houdini tumbling. However, whichever one of these you use, it's not going to affect this tutorial, but I suggest that maybe you try classic Houdini tumbling for now. Now, the one that I do want you to change here is the default homing. And in fresh install of Houdini, the default homing is set to oblique. And for this particular exercise, I want you to set that to Z-axis. And then I'm going to have you come back up to the pull-down menu again, and I want you to choose Objects and Geometry. And the option that I'm going to have you change here is the default geometry display. Currently, it is going to say Show Current Operator. And for this particular exercise, it's important that you change that to be Show Display Operator. And again, you may choose to set these back to system defaults at a later time when you become a bit more familiar with Houdini. But for now, I want you to use Show Display Operator. And then at the bottom of the parameter window here, I'm just going to say Accept. Now, when you move into the Houdini viewport, if you just use your left mouse button, you'll be able to tumble this viewport around. And then I'm going to have you press the H key for home. Now, if your viewport does not home directly down the Z-axis the way mine is here, you may still have this oblique homing. What I want you to do is go to this pull-down button here that says Perspective 1, and I'm going to have you left click and choose Home, and yours probably still says oblique. I'm going to have you change this to be Z-axis Home. And now if you press the H key, you should be homing directly down the Z-axis the way I am. Now, this is a desktop preference, so what I need to have you do now is also choose up here in the top menu bar to choose Windows, Desktop, Save Current Desktop. and then OK that as well. And now, should you use the left mouse button to tumble around in this window, if you press the H key, you'll now home directly down the Z-axis. You're also very comfortable and very familiar with the construction plane from other 3D packages, and you probably are accustomed to having that displayed at all times. Again, for this particular exercise, I'm going to have you toggle the display of the construction plane off. And you do that just by clicking on this icon here. And now the construction plane is not displayed in the viewport window. Most Houdini users get very accustomed to not using the construction plane unless they want it. And so to just clean up the perspective view window, they toggle this off. Now once this has been toggled off, I really should do a Windows desktop, save current desktop again. But should you find that when you re-invoke Houdini that the construction plane is displayed, you can just come up here and toggle it off at any given time. The one last thing that I'm going to have you do here is there's currently no lighting in the Houdini scene. And until you start putting in your own lighting, Houdini uses a default lighting system. And I find that the specular highlights are a little bit harsh in that lighting system, and I like to toggle the specular highlights off. The easiest way to do that is just click in the viewport window and press the D key for display options. I then want you to move into the folder tab called Effects, and you'll see an option here for lighting, says normal lighting, and down below you'll see an option for specular, and your specular option will be toggled on. I would like you to toggle that off and then choose Save as Default, and then you'll have to OK this menu, and then you can close this window down. And that'll get you set up with some system defaults that I've used for this tutorial, just so as when you're following the tutorial along that everything will operate and look the same as it does in the tutorial. Now when you first invoke Houdini, you'll be presented with the standard desktop display. At this point, you may very well have the construction plane displayed in the viewport window, and for this particular exercise I prefer that you toggle that off. So if you just move up to this little icon here, you can toggle the display of the construction plane off at this point. It can be toggled on and off at any time, but I'm going to have it toggled off at this point. Now Houdini's interface is actually broken up into 4 main panes, if you will, and this pane here is the viewer pane, and of course that's going to show you the geometry by default in the perspective window. This pane here is known as the DAG node layout pane, and this is where object nodes, SOPs, etc. will be displayed, and where you'll actually see the procedural networks created by Houdini that gives its procedural nature. This pane up here is known as the parameter pane. Now, whenever a node is selected in this pane, the appropriate parameters for that node will be displayed in the parameter pane here. Now, the last pane is this pane that stretches across the entire interface here at the top, and this is known as the shelf tools. Now the shelf tools are there to allow you to work much more interactively in the viewport window in a way that you might be more accustomed to from other 3D packages. They'll save you a lot of time and effort in some cases, and in some cases I highly recommend that you do use the shelf tools. In other cases you may find that you like to work more interactively with the SOPs themselves as opposed to using the shelf tools. But you'll only know that once you get working with Houdini and find your own way. Now Houdini also has 2 main operating modes that you want to become familiar with, and those modes are view mode and select mode. Now at this point when we first fire up Houdini, we're in view mode, and really until you've got any operators in place you're probably going to be presented with view mode at all times. Now when you're in view mode, you'll notice that the cursor here in the viewport window is displayed as a little hand, which represents you are in view mode. You'll also notice at the top of the viewport window here there's a little icon that looks like a camera, and it indicates that you are in view mode at this point as well. Now at this point it's important to remember that we don't have a camera in here, but you are in view mode. So you're not viewing through a camera, you're effectively viewing through your own eyes, as if you had removed yourself from the camera position and you were just walking around the scene. Now the other mode that Houdini has is the select mode, and if I press the S key, actually I have to click in the viewport window there, if I press the S key I'm now in select mode, and you'll notice that the cursor has changed to a selection cursor. It looks like a little arrow, and up at the top here the notation that said view has now changed to select mode. Now you can switch between select and view modes at any time by using the escape key to return to view mode, and as previously mentioned, the S key to enter back into select mode. So if I press the escape key, I'm back in view mode again. Now when in view mode, you can then use the mouse buttons to manipulate the view. So if you use the left mouse button, you see that you're tumbling. If you use the right mouse button, you zoom in and out. And one that I like a lot is the scroll wheel, or the middle mouse button. Using the scroll wheel you can pan in and out. Now it's important to remember that this view manipulation, when you're in view mode and you're working in this manner in the viewport window, that you're not affecting the camera in any way at all. In fact, at this point there is no camera in the scene. But even if there was a camera in the scene, and we'll look at manipulating the camera later on, if you go to view mode and change the view in this perspective window, it's as if you had actually physically left the camera and now you're walking around the scene looking through your own eyes. So this is not manipulating the camera, and that's important for you to understand. Now this will start to make a lot more sense when we actually have some geometry in here, and you'll be able to see what is displayed in these panes and how this sort of all fits together. Now another hotkey that you'll use quite often is the H key, and the H key will home the viewport window. So if you press the H key at this point, sorry, I had to click in the viewport window there to activate it. If you press the H key at this point, you'll now see that we've homed the viewport window and we're looking straight down the Z axis. Now I'm going to use the shelf tools here to begin the construction. Later on I'm going to give you more of an idea of how to work with the SOP networks themselves, but at this point we'll work with the shelf tools, and you'll see that Houdini is building the surface operator networks for us. Now I want to be careful here. I want you to hold down the control key. Hold down the control key, move up into the shelf tools in the create folder, and I just want you to select tube. And when you do that, a tube will be placed at 000 in the world, and as you can see, you're now looking at it in shaded view mode. Now the reason why I had you hold down the control key, the control key ensures that the geometry will be created and placed at 000 in world space. If you didn't hold the control key, you would then be free to specify, just by mousing around the viewport window, you could specify the location for the object to be created. But quite often you do want to create your objects at 000, and then you'll move them into the appropriate location a step or two from now. Now, the manner in which the geometry is shown in shaded mode is determined by this icon here, which is the icon for display geometry in shaded mode. And the hotkey to toggle between the shaded mode or wire mode is W. So if you press W, you're in wireframe mode. If you press W again, you're in shaded mode. Now, this icon also allows you to select which shaded mode that you want to toggle between. So it'll always toggle between wireframe and shaded mode, but the shaded mode that it toggles into, you can set. And you can see we could have wireframe banding box, shaded banding box, straight wireframe, hidden line removal. There's several here. Flat shaded, smooth shaded, and smooth wire shaded. Now I know a lot of you like to work in smooth wire shaded if you've been working with other 3D packages. So I'm going to select smooth wire shaded as the toggle here. So again, the hotkey is W. Now it's also important to realize that these hotkeys, H homed the window as an example, and all of these hotkeys are sensitive to the window that is currently active. And if you don't understand that, sometimes it can get confusing because you press a key and something happens and you're not sure why, that sort of thing. And of course it takes a bit of time to get accustomed to hotkeys and remembering them. But if you remember the viewport window here, I'm just going to use the left mouse button. And sorry, I'm not in view mode here, so I'm going to press escape. I'm going to use the left mouse button here just to tumble the viewport window. I press H and I home the viewport window. I press W, I go into wireframe. I press W, I go back into shaded mode. But let's now move over to the DAG node layout window. I'm going to click in that window so it is now active, and I'm going to use the scroll wheel just to zoom in here, and the node is now lost somewhere down here in the corner of the screen. Now with this window active, if I press the H key, I do in fact home that window just as I homed the viewport window. Now the W key, however, is a little bit different when you're in this window, because if you press the W key here, you now open up a list view of all of the objects. And if you don't know that, then it sometimes gets confusing because you plan on toggling back to wireframe, but you haven't activated the viewport window, so Houdini feels that you want to issue the W hotkey in the DAG node layout window. So it's just a good thing to remember. But it is a toggle again, so if I press the W key, then I go back to the regular node display as opposed to the list display. Now I want to talk about the DAG node layout window and these nodes a little bit here. And as we continue, I want to actually be in wireframe mode to illustrate a few things. So I'm going to ensure that the viewport window is active. I just clicked in it and pressed the W key. So I'm back in wireframe mode, and perhaps I'll tumble a little bit just so I have a better view of that geometry. And now I've gone over and selected the DAG node window again. Now in the DAG node window, you'll notice at the top of the DAG node window it says OBJ, or object. Now that's indicating that we're at the object level, and that same notation happens to be over here at the top of the viewport window as well. So this is indicating that I am at the object level in terms of the interface, and it indicates then that it alerts me then that this is an object node. Now an object node is really just a container, and that container holds all of the surface operators or any other procedures that are actually necessary and or used to create the geometry. So this to some of you will equate to world space geometry, world space position. That'll come into play in a minute, but just realize that an object node is basically a single node which is a container for which all of the operations necessary to create this geometry exist in. And there are two flags on here, and these are very important to understand as well. The blue flag is the display flag. Now there's only one object in here, and if I toggle off the display toggle the display flag off, I see no geometry in the viewport window at all, because there was only one piece of geometry and I just toggled its display off. So the blue flag then is the display flag, whether or not that geometry will or will not be displayed. Now earlier on I mentioned to caution you about simply clicking on things to see what happens. And the reason why I say that is that this little green flag is not quite as intuitive. If I turn the green flag off, nothing appears to happen. But what I've actually done here is I've now made this object non-selectable. So I can't accidentally or even purposely select that geometry in the viewport window anymore because I have made it non-selectable. So for example, if I went back over to the viewport window, I click to make it active, hit the S key, and try to select that geometry. I can't select this geometry any longer because it's been toggled into a non-selective mode. Now, if I were to toggle the selection button on again, now I can actually select that geometry again. So that's what these two flags are for, and it's important, of course, that you understand those. Now, as mentioned, this is an object container that simply contains all of the surface operators necessary to create that geometry. And the geometry that we're going to create is actually going to be a staircase. So I'm actually going to rename this node to be staircase. Now, seasoned operators might caution a little bit the way I'm going to construct this staircase, because for illustrative purposes and to demonstrate an awful lot of nodes to you, I'm going to build the staircase as one entire object inside one object container. But I would probably be best advised to create several objects, and we'll look at that at the end of the exercise. For now, we'll just put everything in this one container. Now, when the object was initially laid down in the viewport window, you may have noticed, I don't think I made mention of it, you may have noticed that there was a display of some transform handles here as well. But now I took you off doing a few other things. They're no longer displayed because I think we're all back in view mode here. But it's easy to get back to where that situation was. Let's select the object node over here in the DAG node layout window, move over into the viewport window, and press the enter key. And now you will see those transform handles that I was talking about. Now, the thing that you'll notice here is that once that's happened, we're no longer in view mode anymore. Just by the display of the cursor icon, I know that I'm in a selection mode. But anyway, before we get working with these handles, I mentioned before that this was the parameter window, and in fact it is. And the parameter window gives us a number of parameters relating to this object. Now, you can see there's translate, there's rotate, there's scale, for example. If I were to change any one of these parameters, I'm affecting the entire staircase. I'm not only affecting the tube, which of course is the only piece of geometry related to this staircase at this point. Again, because these are object level transformations, they work on an object as a whole. So everything that's in this container is basically considered to have a pivot point at 0, 0, 0 in world space, and any parameter changes I make here are going to affect the entire object. And again, as we get working on the exercise, that's going to become very clear. I just wanted to point that out now so that you can see how they relate to the transform handles that are displayed here in the viewport window. Now, the display handles that are displayed by default, there are only 2 of 3 available handles. And the handles that are displayed are the translation and rotational handles. The translate handles are very familiar to you from other packages, I'm sure. I can grab the handle and move up the y-axis, and I can grab the handle and move on the x-axis. And here's where your view modes also become important. I may now want to rotate this, and I can do that very easily, of course. Here's the rotate cage. Okay. So I'm rotating about the x-axis, rotating about the y-axis. And now perhaps I want to rotate I rotated around the z-axis there a minute ago. Now maybe I want to rotate around the y-axis, and it may be a little bit difficult to see in this viewport orientation. So if you remember, I could press the escape key to return back to view mode, but I don't want to do that in this case. The reason for that is that if I use the escape key to go back to view mode, then I have to use the S key to come back to select mode again. Then I have to click in the viewport window in order to get the handles to display, and I don't want to have to go through all of that. So at any given time, if you hold down the space bar, notice that I'm now in view mode. If I release the space bar, I go back to the select mode where I was. So the space bar is extremely useful in order to temporarily return to view mode. So if I hold down the space bar, I can now manipulate the viewport window, release the space bar, and there I am in select mode where I was before. And now I could perhaps rotate in an orientation that maybe wasn't as clear to see before, that sort of thing. Okay, so at any given time, hold down the space bar and you temporarily go back into view mode. All right. Now the same thing happens here with homing the viewport window, because the H key that you use to home the viewport window is really a view manipulation tool, and we're not in view mode anymore. So if I press the H key, nothing appears to happen. Because I'm currently in select mode, I want to press the space bar to temporarily return to view mode. Now press the H key, and now I can home that geometry. Okay, now of course it's not going to home in the same manner that it did because I have all these rotations on it. But if you look at the axes gnomon here in the viewport window, you can see that we have homed and we are now looking down the z-axis again. The other thing that you may have noticed is that as I use any of these controls, the parameters in the parameter window are updating to show me the exact amount of rotation or translation, anything else that I might change about the geometry. I mentioned that by default you have the translation or the translate and rotate handles displayed, and very often you'll want to scale as well. So there are hotkeys for each one of these tools. Now, for example, if you only wanted the transform handles to be displayed, T. And now you only have the transform handles displayed. R will display only the rotational control handles. And if you wanted to do some scaling, E. The E key is the scale handle. Now the scale handles are worth a bit of exploration as well. The scale handles all come out to a point. I often refer to those as the arrowheads. If you grab one of these arrowheads, and it doesn't matter which one of them you grab, notice that you're scaling along all three axes. Okay, so you're doing a proportional scale by grabbing any one of the arrow handles. Now the scale cage itself, if I were to grab here on the Y, now you can see I'm only scaling on the Y parameter. And similarly, I'm going to hold down the space bar and just tumble a bit so that I can get the X scale handle. Now I'm only scaling on X. And of course, likewise, hold down the space bar, tumble a bit again. All right, there's the Z scale. Okay. If you want to scale non-proportionately on any two axes, then you actually use the cage. So here you can see I'm now changing the scale on the X and Y axes. And now I'm changing the scale on the X and Z axes. And here I'm changing the scale on the Y and Z axes. So it's worth a little bit of time just to get accustomed to using the space bar to temporarily switch yourself into view mode, and then working with the various handles to get a feel for how these are going to affect the geometry. And again, to remember that T for the translation handles. Now there's something I've done. I have actually kicked myself out and the handles are no longer displayed. So I'm just going to select the object again. What I did is I probably clicked in the viewport window, which caused things to be deselected. So T for translate handles, R for rotate handles, E for scale handles, and if you want to clear these off entirely, you can just press the same key again. Actually, my apologies there. Pressing the same key again will not clear the handles. I was thinking of a different software there. Um, However, if you do want to clear these up and you don't want to leave the selection mode, a really quick, easy way of doing that is just to come over to this little icon here. And I'm now back in select mode, but I'm not with inside the translation parameters, if you will. So that's an easy way of just clearing that away and putting yourself back into select mode. Likewise, I could now also display the translate handles by clicking on this icon, the rotate handles with this icon, the scale handles with this icon, and the defaults again, which are the translate rotate handles with this icon here. So these icons can also be extremely useful. I'm just going to press escape here to go back into view mode. Now before I continue, there's a couple of other things that I do want to point out about these parameters as well. Notice when the parameters do change in the parameter window, any parameters that are no longer the default conditions, so for example the XYZ translate, rotate and scale parameters have all been changed. You'll see that Houdini displays those in bold, and that's very useful because then you know which parameters you've changed, which parameters are no longer the system defaults, and that sort of thing. Now, if you wanted to reset all of these back again to the system defaults, and in actuality I want you to do that here. I want translate to be 000, rotate 000, and of course scale to be 111 as we continue on with this exercise. You don't want to have to go through and do that to every one of the parameters. So you can actually right click on any one of these labels. So for example, translate labels, and I can say revert to and restore factory defaults, or revert to defaults. If I do revert to defaults, they're all back to zeros. Revert to default and revert to default. Now I'm going to go back to the viewport window. I am in view mode, so if I just press the H key, I've now homed the viewport window again, and I'll just tumble it slightly forward, and then we'll go on from here. Now, as I work through this exercise, I've actually reconsidered how I'm going to set up this file and build the staircase. Originally, I indicated that we would build everything within the one object node called staircase, which really wasn't the optimal way of setting up this file. So I think I'm actually going to shift gears here a little bit and show you the proper way that these files should be set up. So I'm actually going to rename this object node that we called staircase. I'm actually going to rename this and just call it support pole. And now we'll continue on from here. Now let's move inside the geometry object, or the container which contains this geometry, and have a look at how the geometry is created and how you modify it. Now, as we progress through the exercise, I'm going to show you a number of different ways in which you can interact with Houdini and its interface when you're building and modifying this geometry, and you'll find your own way of working and what works best for you. Now, there are two ways of moving inside the geometry object node, and I'll let you use whichever technique you like to do. One technique is to position your cursor directly on the pictorial icon of the node. And the reason why I say that is that you want to be careful again not to toggle one of these flags on or off. So try to target the pictorial icon in the middle. Or the other thing you can do is use the I key. Now in this case, I'm going to use the double click method. Now once I double click, I've dove down inside of the geometry object, and I'm now inside that container, if you will, and this is known as the SOP level, or surface operations level. And you'll notice that the path here is updated slightly. We're now in object support pole. Now in the viewport window, you may currently be viewing the transform handles on the geometry. Typically that will happen. There are some cases where it doesn't happen. But the easiest way to get those transform handles back is simply to move into the viewport window and hit the enter key. And now you have the familiar transform handles back again. Now the technique I'm going to use here is to interactively work in the viewport window. You're already familiar with the scale handles from the previous part of the exercise. The scale handles in this particular case, there isn't actually a scale parameter here. So the scale parameters in this case are actually going to drive the radius and the height parameters. And I've decided that we're going to use a radius here of 0.1. So I'm going to take the scale, the X handle, you can think of it that way here. Actually we'll want to scale on both the X-axis and the Z-axis. So I'm going to choose the scale cage that lies on those two axes, which happens to be the blue. And I'm just going to interactively scale this down. And you can see the parameters in the viewport window updating. And I'm not actually going to go to 0.1 at this point, but you get the idea. Now another very useful hotkey combination, of course, that's familiar through most programs is Control-Z to undo a function. So I'm going to use Control-Z at this point to put the radius back. Now the reason why I did that is you can see that as I scale these back, it's a little bit difficult to actually get 0.8 here because I'm getting rounded off numbers. So if I do Control-Z again, what I'm going to do this time is I'm actually going to use the middle mouse button, which is actually the scroll wheel as well here on my system. And you'll get this ladder jack that comes up. And you can see that you can move up or down the ladder to choose increments of 1, 0.1, 0.01, etc. So I'm going to choose 0.1 here. And then just mouse left and right across the screen. And now you can see that I'm decreasing by even units of 0.1. So it's very easy to get down to the actual radius of 0.1 that I want. Now similarly, I'm going to do the same thing with the height parameter, and I'm going to adjust the height to be 5.5. So I'm going to do the scaling here using the scale handle for only the y-axis. And again, I'm going to middle click here. This time I'm going to choose an increment of 1. And I'm going to scale this up to a unit, or a height of 5 units. And I actually want 5.5 in this case. So I'm going to hold down the space bar, tumble just slightly, middle click again, and this time I'm going to use 0.1. And I'm now going to just scale up to 0.5. So now if I use the space bar again, because remember we're not in view mode, we're inside the tube stop, so we're actually in a select mode of sorts. So I'm going to use the space bar and home the viewport window again. So at this point I now have a radius of 0.1, 0.1, and a height of 5.5 for the support pole. Now I'm also going to move the support pole off center. Rather than have everything happen at 0, 0, 0 in the world, I'm actually going to move this support pole off slightly on the x-axis. And I'm also going to move it up on the y-axis as well, because at this point the middle of the pole, if you will, is sitting at 0, 0, 0 in the world where the construction plane is. So you could do exactly the same thing here. I'm just going to use the space bar and tumble again a little bit. Sorry, I need the escape key there. Space bar and tumble a little bit. Now of course I can't see the construction or the transform handles anymore because of that click that I did in the viewport window. So remember, a very easy way of getting them back is either just hit the enter key again or use these icons that were discussed a little earlier. Now in this case I want the transform handles, and what I have here is the transform handle and the scale handle. Now we're done with the scale, and it doesn't matter whether it's displayed or not, but remember you can use the T hotkey to display only the transform handles. And I'm going to transform this only on the y-axis. So again, I'm just going to choose that, and we want to move up, sorry, it's at 2.5 units. And again, it might be difficult to get to 2.5. So I could use the ladder jack again by middle clicking. But just to show you something else here, I'm just going to release this and leave it at whatever it was. In my case it's 1.3. I can also interact directly with these parameter fields. So the center in this case is X, Y, and Z, of course. I'm going to double click in the Y field just to select that value, and I can manually enter in a value of 2.5 as well. And now the support pole has been moved up 2.5 on the Y-axis. And I'm going to use that technique because it's very quick and easy, just to do the same thing for the center on X. And I'm going to move it to negative 0.8 units. Now I'm going to use the space H combination again to home the viewport window again. And I just want to take a moment here to talk about primitive types. Now in this particular case, and I mentioned before that Houdini offers you many geometry types, and that primitive was actually a geometry type you're familiar with, and the geometry types are here under this primitive type button. You're very familiar with polygonal geometry, for example. There's NURBS geometry. They're both used quite often. But in this case, the geometry defaulted to be primitive type. Now, primitive type may be a geometry type that you're not familiar with. It's very, very efficient geometry, but it also has some limitations as well. Now, if you were to middle click onto this node, you'll get information about this geometry. And when I middle click, I see that I have 1 point, 1 primitive, 1 vertice, 1 tube. So in other words, I only have one piece of geometry and it only has one single point on it. Now if I were to change this to be a polygon, for example, and did the same thing, I'm going to middle click on the pictorial icon of the operator, I now have 20 points. Notice that I have 10 primitives. So each one of these, or this geometry actually is made up of 10 polygons. And that's where I get, and what Houdini refers to as 10 primitives. So there are 10 primitives, 10 polygons. All right, there are 20 points and 40 vertices. So I know that there are shared points on this geometry and that it is a polygon, but it does have 10 primitives. I know I keep going on about that, but that's something that you're going to have to get accustomed to. Now in terms of NURBS geometry, if I changed it to NURBS geometry and looked now, I have 20 points, I have 20 vertices. I now only have one single primitive and one NURBS surface. And that'll become more clear as you work with Houdini's geometry. But let's go back to the primitive type. Or actually, before we go back to the primitive type, let's change this back to polygon because you're very familiar with polygons. And over here in this set of icons, this is the icon to turn on the display of points. So if I turn on the display of points, you can see that we've got 10 points around the top, 10 points at the bottom, and of course these are just pieces of polygonal geometry connecting those points. So that's pretty familiar to you. But let's change the geometry type back to primitive again. And now when it's primitive geometry, and I may have to tumble and dolly out there a little bit, there should be, although it isn't displaying, there should be 1 point shown at the middle of this geometry. Because if you look here, we do have 1 point. So there's a little display problem there, but we should see a point here at this point on the geometry. So you can notice that with primitives, you don't have the point control. I was able to change the height, I was able to change the radius of this, of course, but I couldn't modify it into some other shape. I couldn't simply select a point and make a large bulge or something in here because there are no points on this geometry. And that's what makes it so particularly efficient. If I don't need all of those points, for example, and in this case, this is just a support pole, and it's not going to change at all except for its radius or its height. So it might be very advantageous for me to just use a primitive type of geometry because it's very, very low in point count, it's very efficient. Now the other thing that you'll notice, and because primitive geometry is limited, is that you'll notice these sort of brown colored crosshairs inside the geometry that almost kind of look like a hull structure of sort. Whenever you see those, that's your indication or your alert that this is a piece of primitive geometry. And the reasons for that will become clear a little later on as well, because there are limitations, as I said, with primitive geometry. For example, let's say you had two circles that were primitive geometry. Because there are no points on the edges of that geometry, we could not skin them together to create a surface, for example. Right? So enough about that for now. You'll become more familiar with the geometry types throughout this exercise. I'm just going to home the viewport window again. So that's it for the support pole. The support pole is actually now created. We have the radius that we wanted, we've changed the center, we've changed the height, and we did that all within the tube SOP itself. There were no other operators necessary, although I could have made those transformations with another operator, and you'll see examples of that as well. Now, at this point, remember, we are down inside the SOP level. We're inside that container. And the reason why I'm pointing this out is I'm going to show you a couple of different techniques for creating additional pieces of geometry that are unique unto themselves. In other words, they're separate geometry containers themselves as we progress. But in this particular case, I wanted to show you, actually, just before I move on, I notice I've still left the point display on. I'm just going to toggle that off so that things don't get too busy. There's a couple of ways of moving from the SOP level back up to the object level again, where we could create a new piece of geometry. One of the ways of doing that, and before you do anything, I'll just explain both ways. One of the ways of doing that would be to click here directly on where it says object. This would move us back up to the object level, because again, this is sort of a directory structure, if you would. So we're in the directory object and in a subdirectory support pole, if you want to think of it that way. So I could just click here to go directly back to this this directory. You'll notice, however, there are bookmarks as well, very much like you see in the internet web browsers. So if I were to click the back button, I go back to the previous location, if you will, that I was at. So I'm now back up at the support level and at the object level, and at that point it goes gray because there's no history. I can't go further back. If I select the forward pointing arrow, of course, I move back into the network where I was before, and I hadn't gone any further, so this one grays out as well. So easy to move back and forth that way, or again, as I said, just click on the object directory here to move back to the object level. So at this point, I do want you to be back at the object level as we continue and create a new geometry object. I'm just going to move over into the viewport window and press escape again. So now let's create another piece of geometry that will represent the stair treads themselves. And I'm going to use the shelf tools to do that again. So we're back at the object level. Here's the object for the support pole, of course, and notice there are no transformations at all at the object level. As far as the object level is concerned, the geometry's translate is 0, 0, 0. Rotate is 0, 0, 0. Scale is 1, 1, 1. So it's important to realize that what's happening here is that the object level, it's picking up all of the or any transformations or changes made at the SOP level, of course, because they're being fed back up here to the object level. Now, something else that you'll want to consider, it's not coming into play right now, but just realize that the pivot point is at 0, 0, 0. The pivot point is actually here. The geometry was offset from 0, 0, 0 in the SOP network. But anyway, let's go ahead and create the stair tread, and the stair tread is actually going to be created just as a simple box object. So once again, I'm going to use the control key and the shelf tools. So I'm going to hold down the control key, move up to the create shelf tools, and get a box. Now that places a box at 0, 0, 0 in the world. Now I want the treads themselves to be 2 units on X, 0.1 unit on Y, and 1 unit on Z. But I'm not going to do that here at the object level. For the most part, I usually leave these transformations at their default, and we actually move inside and do the modifications in the SOP network itself. So again, let's double click on actually before we do that, let's rename the box object itself to be tread. And we'll double click to go inside. Now, once you move inside the SOP to the SOP level for the stair tread, you have a box SOP in here. Notice that we see both pieces of geometry in the viewport window. And the reason for that, if I move back up to the object level again, the support pole is one object and its display flag is toggled on. The tread object is another object and its display flag is toggled on. So if I double click again to go back into the SOP network, when you're inside a SOP network, you'll actually see all of the geometry whose display flags are toggled on at the object level. And of course we want that right now so that we know how to position the box itself in relation to the stair tread. So as I mentioned, you could use the transform handles here if you want, if that's the way you like to work. I sometimes just find it as quick and just as quick and easy to use the parameter fields here. So what I'm going to do for the size on X, as I mentioned, I want this to be 2 units on X, and press the enter key. And for Y, I want it to be 0.1, so I'm going to select this value and do 0.1. Press the enter key, and now we have something that represents the stair tread here. Now just to clear up the interface here, I'm going to go back over to the viewport window and just click in the viewport window, press the escape key. I've gone back to view mode and now I don't have the transform handles and that sort of thing. When you're doing an introductory level exercise like this, there is a lot of explanation. There are just so many interface features and buttons and icons, and I want to try and cover as many of those as I can for you. That was the part of the intent of this tutorial. As mentioned, at this point we see both the support pole and the stair tread itself, and the reason for that, as I explained, is that both of those objects have their display flags toggled on at the object level. Now there is a template geometry function in Houdini, and we'll be using that, and a lot of people ask me that because of course you're accustomed to templated geometry in other 3D packages, and of course Houdini has the same thing. But there are some other display control options and icons that I want to point out to you as well. So again, if I can just reiterate, we're looking at both pieces of geometry right now, the support pole and the stair tread. Now remember that the support pole is one object and the stair tread is another object, and we're inside the stair tread object now. Now if we didn't want this support pole to be actually shown as the same display as the stair tread, if you want it for what you sometimes think of as templated geometry, then let's take a look at this icon up here that says show all objects, control visibility of external objects. Well, right now you'll see that all these 3 objects, if you will, in the icon all appear to be shaded the same, so you're displaying all objects. However, I can left click on here and I can say ghost other objects. And what you see now is the support pole as a ghosted image here, and you see the stair tread as a displayed object. And you'll notice that the icon has changed here to have some ghosted look to it so that you know that function is toggled on. Now there are other times when you want to clear up everything and just focus on this piece of geometry alone. And to do that, you could simply say hide other objects. So now, even though the support pole has its display flag toggled on at the object level, you no longer see it in the viewport here because you said to hide all other objects, with the exception of the object that you're working with, of course. And you can see that the icon now, the other objects appear to be hidden. So just for the heck of it, let's work with ghost other objects in this case. So I've just set this to be ghost other objects, and now we'll continue with the stair treads. Okay, now to have a little bit of fun here and to get these stair treads copied and rotated, etc. Now the designer came up with some specs for us, and he decided that he needed 12 stair treads. And he also decided that based on our model, he needed each one of those stair treads to be moved up the y-axis 0.35 units. So I'm going to show you a bit of a different technique here in terms of editing SOP networks and adding SOPs and that sort of thing. Now you'll notice that the SOP has an input connector to it and it has an output connector to it. Now the easiest way to append SOPs to here is to do this interactively as well. But what I'm going to do is I'm going to right click on the output connector from the box SOP. Now what I want to do is I want to copy these stair treads. So I want to find a copy SOP. So the next thing I'm going to do is press C and O. And what Houdini does is finds us all of the SOPs that begin with the letter CO, and here's a copy SOP. So I'm just going to select the copy SOP, and as I move it around you'll see that there's a connector, a dashed connector line between the two of these, and I can just place the copy SOP underneath the box SOP and click to place it. And now you'll see that the input from the box SOP is fed into the input of the copy SOP. Now in terms of the copy SOP, there's actually two input connectors, and you'll sometimes find one input connector, sometimes two, sometimes three, and on the odd occasion there will be more. Now if you're uncertain as to what the input connectors are, you can middle click directly on an input connector and Houdini will tell you what it's expecting to find. So if I middle click on the first input connector, input 1, Houdini is telling me that it's expecting to find the primitives to copy. If I middle click on the second input connector, it's telling me that it's expecting the template to copy too. Now whenever there are multiple input connectors, the first input connector is virtually always mandatory. The other input connectors are usually optional depending upon what it is that you want to do. And in this case we only need the single input connector. So I'm going to toggle the copy SOP's display flag on. Now at this point nothing happens because the number of copies here are set to 1. I just have 1. Now the thing that you have to remember here is the number of copies. The value that you put in here is actually the total number of objects that you want. So in this case he said that he wanted 12 stair treads. So let's place 12 in there, put 12 in there. Now again nothing appears to happen. However, if we look at the information coming out of the copy SOP, I have 72 primitives here. Now each one of these boxes, if you will, or stair treads, they're actually 6 primitives. There's actually a top, a bottom, and 4 sides. And we have 12 of them, so 12 times the 6 sides, of course, gives us the 72 primitives, or 72 polygons. So the next thing is we know that he wanted each one of the treads to be moved up 0.35 units on the y-axis. So let's go to the translate parameter and let's give 0.35 units. So now we in fact have 12 stair treads and each one of them are moved up the y-axis 0.35 units relative to the previous tread. So that's exactly what we want. Now he also indicated to us that there needed to be a 27-degree rotation on each one of these stair treads. So at first we might figure we'll just go into rotate and we'll tell Houdini that we want to rotate those 27 degrees. And that's not really giving us what we want because of course each one of the stair treads has been rotated based on its the pivot point of the original stair tread. And if we look here, the pivot point is actually set to 0, 0, 0. So we're actually rotating about this point here, and you can actually see the pivot point here. So we're rotating about this pivot point, and that's obviously not what we want. We need to have that pivot point. Now, I don't have to do this, but I'm going to set the rotate back to 0. And there's the pivot point. Now the pivot point needs to be in the same location as the center of the support pole. And if you remember back to the support pole, we readjusted or offset that support pole negative 0.8 units from 0, 0, 0 in the world. So I actually need to take the pivot point here on the x-axis and I need to move that pivot point negative 8 units. So negative 8 units has now put that pivot point in the center of the support pole. So now when I do a rotate of 0.3, no, sorry, we wanted a rotate of 27 degrees. If I put a rotate of 27 degrees on the y-axis, Now the treads rotate from that pivot point, and they're actually giving us the exact effect that we want. So again, I'm just going to home the viewport window here for a moment, and now we have 0.35 unit translation on each copy, and we have 27-degree rotation. So they're cumulative. So each stair tread is moved 0.35 units in relation to the previous copy, and each one is rotated 27 degrees on the y-axis relative to the previous copy as well. And of course, you did catch my audio mistake there. The pivot point was to be moved negative 0.8 units on the x-axis, not negative 8 units, as I said. And now a bit more interface stuff, sorry. At this point, you've been working and all you've seen is Houdini's single view, the perspective window. Now, screen real estate's often at a premium, and most Houdini users will do most of their work in this one single view pane. Now, many of you are accustomed to the 4 view panes because by default that's what a lot of systems are set up to display. And you're just accustomed to working that way, and some new users are a little bit uncomfortable not having those. But if you give it a chance, you'll find that you're working and doing most of your work in the perspective view window. However, there is an icon here that allows you to display multiple windows at any time, and that's this icon up here. Now, if I left click on this icon, I can choose the familiar 4 views that you're accustomed to. Now I have the top view, the perspective view, the front view, and the right view. And the perspective view will also always be independent from any other views. So I can tumble, dolly, do whatever I want here. And let's look at the top view, for example. Now if I dolly in the top view, and of course you can't tumble because these are orthographic view windows, but if I dolly in the top view, that doesn't affect the front or right views. Okay, at this point they're all independent. Now if you would like those to be linked together, there's also an option here that says link ortho views. And now all of the ortho views are linked together, so they all react to the dolly or the zoom, if you will, in the same manner. And you can link or unlink those at any given time. Now you can spend some time here exploring, but Houdini also has a number of other default views as well. 3 views, split bottom, for example. Now you have a perspective on the top, and you have a front and a right on the bottom. I'm going to go back to single view here. And you'll see there are also hotkey combinations for any of these as well. So at any given time, if you want to toggle into the 4 views, you can simply use Control 2. And now you've got the 4 views. And the most common ones are Control 1 and 2, because at this point, if I did Control 1, I could switch back to the perspective view. So it's very easy to get these split orthographic views that you're accustomed to. Now I'm going to use the Control 2 hotkey combination here to go back to the 4 split views again. And you'll also notice that at any given time, one of these views will be active. And you know it's active because it's shown with the window identifier and the view identifier, which in this case is no cam. Both of those will be shown in yellow, and there are reasons why that you'll learn later on why you may want to activate one window as opposed to another window, that sort of thing. But the defaults, as you saw, there are quite a few defaults here, but you can also customize these window sets to be anything that you want. For example, let's say you wanted to work with 2 views side by side, and what Houdini will do is give you the top view and the perspective view. But perhaps for some reason you would like this to be, let's say, a front view, and this to be the perspective view. It's very easy to change those as well. Over here, where it now indicates that we're looking at the top view, you can left click there, and there's an option for set to view. And we could say that we want to set this view to be a front viewport. So now I have a front viewport here, and I have the perspective viewport here. So you don't have to use the default split setups that Houdini supplies for you under this icon. You can split the views into whatever you want and then change these. So I could set this view and say, for example, that I want the UV viewport, for example. Now this would be extremely useful if you're doing UV edits and that sort of thing. So you could have the perspective view here as you texture mapped something, and the UV viewport here while you manipulated the UVs. So again, you can change these to be anything that you want. There's a right viewport and top viewport. You get the idea. And then I'm just going to go back and set this to be a single viewport again. Now again, the other thing that you can do in terms of these viewports as well is you don't have to use the split viewports at all. As you saw, you can change any one of these viewports for any display that you want, be it perspective, orthographic, or anything else. And again, you did that by left-clicking here, choosing Set View, and you'll notice that the perspective viewport, top viewport, front and right, and UV all have a hotkey assigned to them. So that makes it also very quick, easy, convenient as well to just switch this single viewport to anything that you want. So for example, if you needed the top viewport or wanted the top viewport at any time, just momentarily, the hotkey, as you saw, was 2. As long as you're working in the viewport window, you could press 2 and we now have a top viewport. And then you could use 1 again to return back to the perspective view. So you would have 1 as a perspective view, 2 is top, 3 is front, 4 is right, 5 is your UV viewport, and then simply choose the 1 hotkey again to go back to the perspective viewport. So again, after you spend some time getting used to some hotkeys and some, the ability to manipulate and customize these views to anything you want, you'll find that it's a very quick, easy way to work within Houdini. Now in this part of the exercise or tutorial, I want to give you an introduction into functions and expressions. Now there are a number of functions built into Houdini, and of course expressions are pretty much limitless. You can build virtually any expression you want. And it takes the whole aspect of proceduralism and live networks even further. It's extremely powerful and used extensively within Houdini. One of the easiest ways to start off and to understand this is to realize that right now there is some type of a positional relationship, if you will, between the location of the pole on the x-axis in particular and the pivot point for the tread. If you remember, we moved the pole negative 0.8 units on the x-axis. And then in order to have these stair treads rotate properly in relation to the pole, the pivot point for the stair tread, if you remember here, had to also be moved negative 0.8 units on the x-axis. Otherwise, as you saw earlier, the stair treads would simply rotate around their own local center at 0, 0, 0 by default. Or I really should say their local pivot point at 0, 0, 0. And they wouldn't line up in the way that we wanted them to line up and rotate around the center pole. So you really do not have to do anything here. We put in a pivot location for the first stair tread, but if by some chance you wanted to procedurally link these together, there's a couple of reasons why you might want to do that. First of all, if the position of the support pole was changed for any reason, then you wouldn't have to worry about coming back here and updating the pivot point on the stairs. Everything would be okay. Now, in all honesty, you probably wouldn't have to do that in this case, because the pivot, if you wanted to move the staircase around in the environment, you would simply go to the object level and we'll move the entire object around as a whole. But this is a perfect opportunity to illustrate functions and channel references to you. Let's move back up to the object level. And we'll go into the support pole. And here's the center perimeter here. So I'm going to actually right-click directly in the X parameter field. And I'm going to select the option here that says Copy Parameter. And I can use the bookmarks, remember? They're very useful. I'll go back into tread now, and for the pivot location where I put the value of negative 0.8, you're going to right click in here and we'll say paste copied references. And you'll see now, if you click on the pivot location again, the actual expression is evaluated to 0.08. If you click on the pivot label again, you'll see that there's actually an expression in here. Now you can use the Alt-E keyboard technique to pull up the expression editor. That's an easier way to view the expression. And I'll just briefly explain the expression to you here. This is actually the channel function, and what you're doing here is you're actually doing a channel reference. You're in fact referencing the location of the support pole on the x-axis to the pivot location on the x-axis. If you look at the expression, CH is the nomenclature for the channel function, and the whole function is enclosed in an open parentheses and a closing parentheses. And inside of here, you notice that the expression itself is actually in quotes. Now that's so that Houdini will actually evaluate this as a string. Now the string that's in here in this function is really just a directory path. And if you think about it for a moment, we've got slash, that takes us back up to the root level, move into the object directory, then move into the support pole directory, move into the tube1 directory, and get me the value of tx. So it's really that easy. Now I'm not going to do any edits here. It's already applied, so I don't need to apply or accept this. I'm just going to close this window. I just opened up the channel editor because it was easier to view the expression with the channel editor. Now I notice on my monitor that there was no color change to the parameter field. That surprises me a bit. I suspect that yours is probably green. Typically what happens is that this field, this parameter field will turn green, indicating to you that this parameter is now being overridden by some kind of a function or an expression or animation, that it's not simply just a value. At any rate, I'm also going to have you show you how to delete those references if you no longer want them. And what you'll have to do is right-click directly in the parameter field for the channel reference or expression that you want to delete, and you're actually going to say delete channels. And now your parameter field should have gone back to the standard color again, and if you click on the pivot now, you'll no longer see the channel reference. You've taken that out. So the channel reference is still in Houdini's buffer because we really haven't pasted or copied anything else. So this time I'm going to have you right click, and last time you said paste copied references. This time I'm going to have you paste copied relative references. And if I click in the field again, you'll see that this time the reference is just slightly different. In this case, we don't have /obj/support pole. What Houdini has actually put in now is .. /support pole. So Houdini's realized that it actually had to go up one level, go up another level, and then into the directory support pole. So this is just this path is just relative to where you are, as opposed to the last function or the last expression that was actually absolute. And you can use either one of them. It's going to work out to be the same thing. Now if you were several directories deep, you know, let's say you were 5, 6, 7 directories deep, then this expression might become quite long. And sometimes it's just easier to follow or read an absolute path as opposed to a relative path. But either way, you're going to get the correct values, so you don't need to really worry about whether they're relative or absolute paths. But if you wonder why sometimes the expressions are written differently, or why those two options are there, that's why they're there, to differentiate between a relative or an absolute path. So in conclusion here, you've just used a channel function, one of Houdini's built-in functions, to create a channel reference between the center of the support pole on the x-axis to the x-axis position of the pivot point on the stair tread. Now we'll look at some basic mathematical expressions within Houdini. In the previous example, you used a channel reference, and in this case, we're just going to use a simple mathematical expression. Now, the rotate value that we used was 27 degrees, and you might wonder where that came from. Well, the designer's specifications actually said that the total amount of rotation on the stair treads must be 324 degrees in order to fit his installation. And with a number of copies of 12, then 324 divided by 12 gave us the rotate value of 27 degrees. However, this is not going to work if any changes are made, and he should decide that the stair treads, that there needs to be 11, or that there needs to be 13, that there needs to be 14, then you would have to constantly come back and recalculate and figure out what this rotational value is supposed to be. But Houdini can take care of that for you very easily with expressions as well. And expressions can be very basic, or they can range to very complex. But let's look at the most basic expression here. And I'm just going to select the value in the Y rotational field. And again, we knew it was 324 degrees of total rotation that was needed. And you can simply divide that by 12, the number of stair treads that we have set up for. And if I press enter, the field will go green, again indicating to you that this parameter is being overridden now by some kind of an expression or animation. It's not just a keyed in value any longer. And if I click on the rotate parameter label itself again, you'll see that that does equate to 27 degrees. But again, that's not going to work if the stair treads are changed to a total of 11 or 13 or that sort of thing. So if you just let your mouse cursor hover over the number of copies label here for a moment, you'll see that there's a parameter called NCY, and that stands for a number of copies. Likewise, if you were trying to you were trying to build expressions in the future, if you look at translate, for example, then those parameters are TX, TY, TZ. Scale, for example, there's SX, SY, SZ. So consider NCY for a moment. So whenever you want to use a parameter as a variable in an expression in Houdini, then to alert Houdini that it is in fact an expression or a variable, and I'm just going to click on the rotate label here again to display the expression, we're going to have 324 degrees divided by $sign. Now the $sign is important because the $sign indicates to Houdini that we're going to take one of the parameters and use it as a variable. And the variable or the parameter again was NCY. Anything that's used as a variable, so anything that's prefaced by the $sign must be in uppercase letters. And again, Houdini tries to help you along. As soon as you put in the uppercase N, Houdini gives you a list of parameters that it thinks you may be referring to, and of course there is NCY. So I can select it very easily there, or I could have typed in $sign NCY myself. So what you've done is you've actually used this parameter NCY, and you've used it as a variable here in an expression. So we now have 324 divided by $NCY, and if I were to press the enter key here now, what you see again is that expression. If I click on the rotate label again, you'll see that it does equate to 27 degrees. So now that this expression is actually set up using this parameter as a variable, then should we change the number of copies, this parameter will update. So let's take a look at 13 treads. Now you can see in the viewport window, if you watch, and I'll just set it back to 12 and watch the viewport window, and you can see that in fact the rotations are changing. You can see it quite easily down here along with the second stair tread. There's 12, there's 13. So we can see that it is adjusting the rotation. Now this variable is not actually, or the result of this expression may or may not update properly here. Sometimes I find that if you just select the rotate parameter again, And that didn't do it here in this case either. I'll select and there it is. So I just had to cause something to refresh here again. But you can see that if we use 13 copies, then the rotation needed is 24.9231. Now, even though that wasn't being displayed accurately, even though you still saw the 27, you see that the math behind actually did rotate the stair treads, and everything was correct. So you can find any one of these, and again for pivot you can see it's px, py, pz, so you can very easily find any one of these parameters and use them as a variable in an expression. Now, just before we continue on, I do want to reset this back to 12 again, and let's see if we can get this to, no, it seems to want to have me select the variable and then the label. But again, the math behind it was working correctly. But I go through that because I have seen people get confused. They change this value, this doesn't appear to update, and it's just a refresh problem there. The math behind did update correctly. Again, that's a good example of a basic mathematical expression, and you can see the power of being able to use the parameters as variables inside expressions. Now, the only thing you have to keep in mind when you're writing expressions is just think back to grade 10 when you were not terribly interested in algebra, and now it comes into play. Remember that multiplication and division is done before addition and subtraction, so that's when parentheses come into play. So you may want to look up some basic algebraic examples, but if you wanted, if you wanted to have something subtracted and get that result before the division happened, then you'd have to put that in parentheses and that sort of thing. So you just have to give some thought to the actual order in which the in which the expressions are going to be mathematically computed, because sometimes we forget that and we have an idea in our mind of what the value should be, but that's not actually the value returned. So that's an example now of a channel reference, and now an example of the basic mathematical expression. Now we're going to move on and create the balusters that will hold up the handrail on the staircase. And keep in mind that the idea behind this tutorial is to show you a multitude of different ways of working in Houdini, in building SOP networks, creating objects, and that sort of thing. There's not one specific correct way to work in Houdini. Some ways are more efficient than others. But again, I wanted to show you a multitude of different ways of creating objects and working in Houdini. So in creating the balusters at this point, keep in mind that what we've done now is we've changed the display of the objects here to ghost other objects, and that's why we're looking at the support pole in a sort of ghosted or template fashion. And we have the display flag toggled on for the copy SOP, which is showing us the copied rotated stair treads. Now, in this particular case, I'm going to just clear up the screen here a little bit to show you how to do that and to makes things easier to add additional objects. So I'm going to change the display mode here to hide other objects, and now we're only looking at the stair treads themselves. Now, in this particular case, what I'm going to do is I'm going to turn on the box object node, or its display flag, so that we're only looking at one single stair tread. And I think perhaps I'll home the viewport window and maybe just tumble it slightly towards me. Now, the baluster for the first stair tread will go sort of to the front corner, sit somewhere near the front corner of the tread itself. But first of all, let's make the baluster itself, and it'll be made out of a simple tube object again. Now, in the previous exercises, or previous parts of the tutorial, I had you go up to the shelf tool and create the objects from here. Now, in this case, I'm not going to do that. If I were to create a new tube object using the shelf tools here, it would create an entirely separate object. And in this case, I'm going to show you how to create another object within this current network. So rather than do that, I'm going to go over and click in the DAG node layout window. I'm going to press the Tab key, and you'll have a menu come up of Houdini's operators. Now, I know that I'm looking for a tube SOP, so I'm just going to press T, and Houdini will then give us a list of all the SOPs that begin with the letter T. So I'm going to select tube here and lay down an unconnected tube SOP in this current DAG node window. And now if I turn on the display flag for the tube SOP, you'll notice that I no longer see the box, because at the object level you can have multiple display flags toggled on because you often want to see multiple objects. In this case, When you're inside a SOP network, you can only have one display flag toggled on at any given time. And you see as I toggle the display flags on, the display changes. So I do want to display the tube SOP here, and we'll just forget about displaying anything else for a moment. Now I want to resize the tube, so I'm going to move over to the viewport window, press the Enter key, which will display the display handles for us. And the first thing I want to do is set the radius for the baluster themselves. And the balusters I've decided are going to have a radius of 0.03. Currently right now they have a radius of 1. So what I'm going to do here is I want to scale on the X and the Z axes. So I'm going to use the scale handle, the blue one that's aligned with the X and Z handles. And I'm going to scale this down to probably somewhere around 0.1. Now again, if you remember, because of Houdini's math, it's so accurate, it's a little bit difficult here to get exactly 0.1. So let's use the Control Z technique to undo that function. And remember again, we're going to use the middle mouse button. And I'm going to scale down by a value of 0.1. So I'm going to take this down to 0.1, then release. Then I'm going to middle click again and choose 0.01. And that's an easy way of allowing me to get down to 0.03 particularly accurately. So now I have a radius of 0.03. Now in order to place the handrail, you're probably going to want in this case to display the familiar 4 split views that you're accustomed to. So remember, I can choose the display icon up here, the viewport layout icon. I'm going to click there and say 4 views, or I could have used the hotkey combination Control 2 as well. And now I have the familiar orthographic windows that you're comfortable with. At this point we're in select mode, so just be careful of that. You can see that we have the handle is displayed in a select mode. So I'm going to use the space bar, and that will allow me to zoom in here so I can get a better view of what's going on. I'm going to home, and I'll home here as well, I think. And now you can either move interactively, as I showed you in the viewport window, or you can interactively move with these parameter inputs as well. So if I wanted to affect only the x-axis, and rather than working interactively in the viewport window as I showed you before, you can also interact with these parameters interactively as well. So I'm going to begin by moving the baluster on the x-axis. So I'm going to middle click directly in the x-axis parameter field here for the center parameter, and I'm just going to start moving in x. And I've got a center now of 1. I'm going to middle click again, go down to 0.01, and I'm going to move that back to, I think in this case perhaps, let's use 0.9. That looks like a fairly good spot. And now I could move over into the Z parameter, and I can now reposition that on the Z axis as well. And in this case I think I'm going to use 0.4. And certainly on the Y you can change as well, because of course we want to bring this up to sit properly on the stair tread, but we want it to be down inside the stair tread just a bit. So I'm going to move this up to 0.456. I think maybe I'll use 0.5 here, and that's pretty good. And now I'm going to go back to the single view window. And if you tumble around a bit, that's in a pretty good location. So I'm going to home the viewport window again at this point. Now I no longer need the template here. I can see that everything's positioned relatively well. So to toggle the template off, I can simply click on the template flag and it toggles itself off again. Now again, if I turn on the copy SOP, I'm not going to be able to see the tube, and if I turn on the tube SOP, I'm not going to be able to see the copies. Now the copy parameters, where we set up the number of copies to be linked to the rotate value, we set up the translate values, etc. That copy SOP is going to work very well for the balusters as well. And you might think that what you do is you just pipe the tube SOP into the second input of the copy SOP, but of course you don't do that, because if you remember when we middle clicked on this input before, it indicated that that was the template to copy to, and that's not what we want. We actually want the box object, which represents the stair treads, and the tube object that represents the balusters, both to be fed into the single input of the copy SOP. So let's just actually call this box. Let's just rename this to be tread, and for the tube, let's rename this to be baluster. Now, in order to get both of these objects piped into the same copy SOP, what I'm going to do is click in the layout window to make sure nothing is active. I'm going to use the tab key again, and I'm looking for merge SOP. So M, E, and there's merge. Now, I don't want object merge at this point. I want merge. And I'm going to click to lay a merge SOP in the layout window. And as its name implies, what the merge SOP does is it merges multiple SOPs together to give them a single output. So I'm going to right click on the output connector of the, left click, on the output connector of the tread and pipe it into the merge SOP. Then I'm going to left click on the output connector of the baluster and pipe it into the merge SOP as well. Now if you display the merge SOP now, you'll see those objects as one single display. And now I'm going to take the output of the merge SOP and pipe it into the first input of the copy SOP. That replaces the input that was already there, and if I toggle the display flag on now, and I'm just going to move over into the viewport window and press escape and home the viewport window, we can now see that you have a baluster correctly positioned on every one of the stairs. Because this copy SOP, the parameters were set up perfectly to take care of the rotational needs, the pivot point change, and the number of copies for the balusters as well. So now I have a baluster on every step. And you could move up to the object display here, and you could choose to ghost other objects again, and now you'll see the pole in relation to everything else. Or of course, if you wanted to, you could say show objects, all objects at this point, toggle yourself into shaded view mode, and you can see that things are coming together nicely. In this particular case, we displayed the baluster and we toggled the template flag on for the tread, and that gave us the tread in a templated display and the baluster in the regular display. Now there will be times when you might want to have multiple templates displayed for whatever reason, and you can turn on as many template flags as you want. Although you can only have one display flag toggled on at any time in a SOP network, you can have multiple template flags. Now in this particular case, they're not going to make a lot of sense here, but just to show you how to do that, if I also wanted for some reason to template the final merge SOP as well, then you can add additional templates just by holding down the shift key. So if I shift click on the template flag for the copy SOP as well, I now have multiple template flags toggled on. However, when multiple template flags are toggled on, toggling any template flag again will toggle everything else off and just leave that template flag displayed. So for example, if I had the tread templated and the copy SOP templated as well, and I clicked on the copy SOP's template flag, the tread's template flag is toggled off, the copy SOP's template is left on, so it'll take another click to get both of those off. And then of course, to continue, I'm just going to display the final result of this network. Now, just for a bit of review here, we should actually rename this object node, because this object node right now is called tread, and we've now included the balusters in there as well. So it might be a little bit misleading to see this object just left with the name of tread. So if you remember, probably the easiest way in this case to return to the object level is to just click here on the object subdirectory or object directory, if you want to think of it that way. That'll take us right back out to the object level, and then let's call this tread underscore baluster. And then remember to get back where we were, double click on the tread underscore baluster node again, and we're back into the SOP network where we left off. Now the next thing we need here is a handrail for the staircase, of course. Now at this point I want to point out to you that that Houdini certainly accepts multiple geometry types within any given file. That's no problem at all. Now at this point, of course, if you middle click on the tread here, you'll see that we have a polygonal surface, and if you middle click on the baluster, you'll see that we have a primitive type geometry. So polygon and primitive type geometry are both being used in this one network. They can be mixed. It's not a problem as well. Now, as we continue on here, the handrail itself is going to be a separate object, and I'm actually going to introduce some NURBS geometry here. The handrail is a perfect application for NURB geometry, where you want a very smooth, flowing surface with minimal geometry in it. So we're actually going to look at creating the handrail now as a piece of NURB geometry and get it in place as well. Now, to create the handrail, and as I already mentioned, that's going to be a separate object unto its own. You could return back to the object level, and then you could create a new object at the object level that represents the handrail. There's nothing wrong with doing that at all. But if you don't want to have to return back to the object level, and it also gives me the opportunity to show you another interface button here, so we're going to use a little different technique here. Now, if you look here, there's an icon here that's actually, if I can get the pop-up menu up, doesn't want to give me a pop-up menu. At any rate, what I'm going to do here is I'm just going to have you left click for a moment, and you'll see that it says Tool Options, Create at Object Level or Create in Context. And by default, this is set to Create at Object Level. So what it's saying now is that if I'm working within this SOP network and I create a new object, that new object will in fact be created at the object level, which is what I want in this case, so the default is just fine. But if you wanted to create a new object with inside this SOP network, then in that case, although you don't do it too often, you would say create in context here. But we want create at object level. So notice that we're still working in the SOP network for the tread and baluster object. And I'm going to use the control button again, because remember that orients geometry at 0, 0, 0 in the world, and the handrail is initially going to be built off of a series of circle profiles. So I'm going to hold down the control key and I'm going to select circle from the create shelf tools. And what you'll see is I do have a circle, in fact, here at 0, 0, 0 in the world, but you'll notice over here that Houdini is automatically taking me back out to the object level. So this object is now created at the object level exactly the way I wanted, without physically having to switch back to the object level and then going to create the geometry. So it just saved a step, but you could have moved back to the object level. Now, circle object, again, is not very descriptive, so I'm just going to rename this handrail, and I'm going to double click on the node to dive down into the network, and we'll create the handrail now. At this point I'm in shaded mode, so I'm just going to click in the viewport window, and I'm going to use W to go back into wireframe mode. And again, the important thing to remember here is that by default Houdini creates primitive type geometry, and in this case I don't want it to be primitive type geometry. I mentioned that I do want it to be a piece of NURB geometry or NURB profiles. So I'm going to click here and say NURBS curve. And now if you look at the information coming out of the circle SOP, you'll see that in fact I have 10 points, 1 primitive, and this is 1 NURBS curve. Now, just before continuing, I'd like to point out a common mistake, especially that new users make, and that's when laying down geometry. Sometimes you'll forget to change the primitive type. For example, in this case, we need a series of NURBS curves to create the handrail, and when you laid down the circle, the primitive type was initially a primitive. Now, if you forgot to change that, when it came to the point of skinning these profiles together to actually create the surface, they wouldn't skin together. And the reason for that, of course, is that because if you forgot and left them at primitive geometry, then remember primitive geometry has no points. It only has 1 point in the center. It's a mathematical representation of the geometry without any points. So without any points on the outside edge of the circle, you couldn't skin them together. So just double check and make sure that you did set the primitive type to be NURBS curve. Now, depending upon what you've done, what mouse clicks and that sort of thing that you've done, when you get back into the SOP network, you see the circle SOP here, and in the viewport window, the transformational handles may not be displayed, and yet if you look over here, you would think that the transform handles should be displayed because the little icon here has been activated. That will happen from time to time, and in order to get the display handles, just make sure that you activate or select the SOP here in the SOP network, and then move back over to the viewport window. And what I'll often do is just do S for select. You'll notice that this icon has now become active, indicating we're in select mode, and then by pressing the enter key, the familiar transformation handles are available to you. And in this case, I think I'll go up to the icon here, and I will ghost other objects again, just so it's a little easier to isolate and see the circle itself. And I'm now going to reduce the size of this circle to 0.9, and I'm going to use one of the arrows on the scale jack, and I'll just again reduce that back to a value of 0.9. And I'm sorry, I forgot here as well. I should have used the ladder jack. So I'm going to use the Control Z undo feature, and then I'm going to select the arrowhead using the middle mouse button, and that way I can very easily adjust this down to a value of 0.1. I think will be a good value to use here. So the radius of the circle at this point has been reduced to 0.1, but the center, of course, is still at 0, 0, 0. And we actually need this profile curve to be positioned up at the top of one of the balusters so that we can begin the construction and the handrail is in the correct position. Up until this point, I've been having you do all of the center changes or positioning and geometry within the actual SOP itself, and you can certainly do that. Now, I wanted to point out, however, that you can also set the transformation scales, rotations, etc. In a very explicit SOP itself known as the transform SOP. So I'll show you how to append that SOP now and how to do the same thing using a transform SOP. So I'm going to have you right-click on the output connector of the circle SOP and press T R because we're looking for a transform SOP, and we can see the transform SOP here. We'll position it in the layout window and toggle its display flag on. Now you may or may not see the transform handles again for the transform SOP. And there's a couple of reasons why that might occur. In this case, we're in view mode, of course, and when you're in view mode, those handles are not displayed. So the first thing you'll try is to just go into the viewport window and press the enter key, and that's most probably going to give you the transform handle. Now, if you ever have any trouble and it does not display, then press the S key to go into select mode, and then enter to display the transform handles. Now you can remember as well that this gives us the rotate and the translation handles, and in this case I don't want the rotate handle displayed, so I'm just going to press T so I only have the transform handles, and I'm going to use the Y translation handle to move up on Y, X to move across on Y, and down on, or X and then down on Y a bit. Now I'm just going to tumble the view a little bit. So you can see that I'm doing this all in the perspective window. And once you get accustomed to this, you'll do a lot of your work, as I said before, in the perspective window. And it prevents you having to change windows and have multiple windows. It becomes very, very efficient and very quick if you give yourself a chance to do this. However, I know many of you are comfortable with the 4 display view windows. So remember, we can come up to this icon here. We can ask for 4 display views, and in that way you can get a much more accurate positioning. So here I can see that I probably have to bring the circle back on the x-axis here. If I'm looking in the right view window, I can clearly see, especially if I hold down the space bar, that I'm now approximately halfway down inside the baluster, and I would probably like to raise that up a little. All right. Now it's difficult to see when we're in shaded mode here, and I want to point this out as well if this window happens to be in shaded mode. If you press the W key, you'll notice that what's happening now is that the perspective window is toggling back and forth, but the ortho views aren't. And the reason for that is that the hotkey is applying to the currently active window. And I can tell that this is the active window because you'll see that the icons here are displayed in yellow or selected. And I would like to actually have the right view window in wireframe mode at this point. But the W key isn't applying to the right view window because it's not currently active. Now to activate this window, because I am in select mode, I'm not in a view mode, I need to hold the space bar. And I'm going to do space N. And that now activates the right viewport window so that when I press the W key, I actually go into wireframe display mode again. Now I don't have the transform handles displayed again, so I'm going to try to use the X, and in that case that didn't help me out, so I'm going to do S for select, enter, and there I am. And now I'm just going to drag this up on the Y-axis a little bit, and I think a position of somewhere around 1 unit is probably going to be pretty good. So I'm pretty close there. I've got 1.00841, and of course if you wanted to be completely accurate, you could just key a value in here, 1. Again, I should have used the middle mouse button in that case. And now I'm going to go back to one single view again, and if I hold down the space bar and tumble around, that's pretty much what I wanted. And if I find that I want to adjust the handrail in a moment after I see it skinned, I can very easily just change the position of this profile curve at that point anyway. Now before continuing, just so that we're completely on track here, I'm going to take the translate parameter and set it explicitly to just 0.9, and I'm actually going to put an explicit value of 0.4 here on the Z-axis. Now we need that profile curve to actually be copied to the top of each one of the balusters. And we've actually set up a copy SOP to do that. We've set up a copy SOP that worked perfectly for the stair treads and the balusters, and it'll also work perfectly for the handrail as well. So we could put in another copy SOP here and go back and do the same procedure that we did, or we could actually get the copy SOP that we already have. Now an easy way of doing that is, you'll notice right now we're in the handrail object or handrail subdirectory, if you will, at this point. I can left click on here and go back to tread baluster. So this is very easy, or makes it very easy to switch between objects as well. So I'm back into the tread baluster, and I want to make sure that the copy SOP is actually active at this point. It probably is. If it isn't, you can just click on it to activate it. Again, you know it's active if it's selected in yellow. So with the copy SOP active, I'm just going to use Control-C to copy the copy SOP. And I'm just going to go back into the handrail object, and I'm going to click just to make sure that nothing is active here for a moment in the layout window. Not that I actually had to. And I can do Control-V to paste this. Now one of the reasons why I deactivated is that once I did Control-V and pasted the copy SOP here, you'll notice that it immediately alerts to me that there is an error. And if you middle click at any given time, Houdini will give you an indication of what the error message is. And in this case, it says geometry not cooked. Well, of course, the geometry can't be cooked because there's no input coming into the copy SOP. So I'm now going to left click on the output connector of the X form, and then left click on the first input of the copy SOP. Now the connection is flowing through correctly. The error message has disappeared, and you can now see, if we look in the viewport window, I'm going to use the spacebar. Actually, I think I'll do escape just to return back to view mode. Now I don't need the spacebar. And now you can see that we do have a profile centered at the top of each one of the balusters. Now the other thing about doing the copy is, when we went back and copied the copy SOP from the tread baluster network, you'll see that the channel references have been brought with it. And that's something else that you also want, because now if you change the number of copies, then this will update as well. Now one thing that you might want to do here, and we can look at it later on, is you might want to make an overall control so that if you change the number of copies in any one of these SOP networks, that they'll automatically update in all of the other SOP networks as well. But I'll go back and show you that in a minute. But for now, we've got everything that we need. Now the next step is to actually skin these curves together to actually create the handrail. And what I'm going to do here is I'm going to right click on the output of the copy SOP, and I'm looking for skin. So we'll do S and K. There's the skin SOP. I'll drop it in and just toggle its display flag on. And now we have a surface that's moving, that's interpolating through. Actually, it isn't interpolating through each one of the profile curves. I'm going to show you that in a moment. But right now we do have a handrail surface constructed. Now there's something very important that you need to understand about the skin SOP when you're skinning to create a NURB surface. And I alluded a moment ago about it not actually interpolating every one of the profile curves. And you'll see what I mean here in a moment. Now the skin SOP will always interpolate. In other words, it will pass through the first and last profile curves. It will definitely honor those. But by default, it may not honor the profile curves in between. Now the easiest way to understand this is, let's just for a moment go to ghost other, actually let's use hide other objects. So in this case we've isolated only the handrail itself. Now turn on the template flag for the copy SOP. Now remember that the copy SOP was the copy SOP that explicitly put a profile curve in the proper location on top of each one of the balusters. Now I'm in view mode, so technically I don't need the spacebar, but I'm just so in the habit of not needing to watch this or not watching this that I use the spacebar quite commonly. Now if you look at the templated profile curves, you'll see that the skin SOP actually did not interpolate a number of these profile curves. It will always interpolate the first and last profile curve. It will always honor those. But what the skin SOP is doing is it's trying to find or calculate the smoothest possible surface between each one of these profile curves, interpolating the first one and the last one, but maybe doing some adjustments as it travels along. Now in that case, we certainly can't have that, because we have to have a very explicit interpolation through each one of these profile curves, because they're sitting explicitly in a very important position on the top of each one of the balusters. So you can see here again, just before I move on, the templated profile curves were not actually being interpolated. So in order to have it to honor those profile curves in the skin SOP, you just want to remember that in order to ensure that, you'll turn on the preserve shape function. And if you toggle it on and off, you'll see the NURB surface change slightly. And when preserve shape is on, you'll notice that the surface actually does accurately interpolate every one of those profile curves. And in this particular case, that's exactly what we need and exactly what we want. So I'm going to toggle the display of the copy SOP's template flag back off again. I only want the skin SOP displayed, and I am going to go back and say ghost other objects, for example. And now you can see that the handrail is interpolating properly and accurately through each one of those balusters. And at this point, you may want to show all geometry as well. You may want to go into shaded mode, and now you can see that the handrail is in position and it's interpolating each one of those profile curves beautifully.